So hopefully you're able to work your way through this. I'm going to go through it with you now very, very quickly, just to make sure you all understand how these trigonometric identities work. So we're asked here to express sine 3 theta in terms of sine theta. Now again, the coefficient of the angle tells you your starting power. So that means our starting point is cos theta plus I sine theta raised to the power of 3. And we've got two ways to expand this. We've got De Moivre's and we've got the binomial theorem. Okay, so we've got to do both expansions. Let's do De Moivre's first, it's easiest. The modulus is 1, so 1 to the power of 3 is still 1. And then the arguments are multiplied by 3, so that becomes cos 3 theta plus I sine 3 theta. So there's the required 3 theta you can see that you need for part of your expression in your answer. The binomial theorem, let's slow down and make sure you all understand how this works. 3c0, 3c1, 3c2, and 3c3. That's the first thing we do in terms of the combination factor. And then after that, you put down your cos theta and your I sine theta. Okay, that's after each one of these combinations. So cos theta, I sine theta, cos theta, I sine theta, oops, stuck for space there, and cos theta, I sine theta, stuck for space there. Anyway, that's the idea. And of course they're all being added to each other, these individual terms, the plus sign in there, and so on. Now, let's work out each term separately. 3c0 is 1, and then we've got 3, 2, 1, 0 over the cos terms, and 0, 1, 2, and 3 over the sine terms. So 3c0 is 1, I sine theta to the power of 0 is 1, so that leaves me with cos cubed theta plus 3 cos squared theta sine theta I plus, now we've got to be careful here. So what have we got? We have 3c2, which is 3. Cos theta raised to the power of 1 is cos theta. And then we have I sine theta to the power of 2. Now this is where we've got to be careful, okay? So I sine theta to the power of 2 becomes minus 1 times sine squared theta. So that will become a negative term, and that will become minus 3 cos theta sine squared theta. And the last one is 3c3, don't worry about that, there, it's in the wrong place. 3c3 is 1, cos theta power 0 is 1, so we end up with I sine theta raised to the power of 3. Now I to the power of 3 is I by I by I, but I by I is minus 1, so therefore minus 1 times I is minus I, so that becomes minus the sine cubed theta I. So just to gather those terms together and equate them, we get cos cubed theta plus 3 cos squared theta sine theta I minus 3 cos theta sine squared theta minus sine cubed theta I. So now you have the De Moivre's expansion equated to the binomial expansion. So let's go back to what we were asked to express. Express sine 3 theta. Well, sine 3 theta, you'll notice, is part of my imaginary answer on the left hand side. So therefore we're going to take that and we're going to equate it to the other imaginaries on the right hand side. And let's see what we get. We get sine 3 theta equals this one, 3 cos, whoops, sorry, 3 cos squared, I'm going to put there. So 3 cos squared theta sine theta, you don't have to write down the i's, minus sine cubed theta. Okay, now what do we want? Sine 3 theta in terms of just sine theta. So we've got a problem, and there's my problem. Okay, that's fine, and that's fine, but that's not. So what I've got to do is I've got to remember that cos squared theta is part of the fundamental trigonometrical identity. cos squared theta plus sine squared theta is equal to 1, which simply means that cos squared theta is equal to 1 minus sine squared theta. Now I need that rejigged identity in order to turn my cos squared theta into 1 minus sine squared theta. So let's do that. Sine 3 theta equals 3 times 1 minus sine squared theta times sine theta minus the sine cubed of theta. Okay, do a bit of tidy up. Sine 3 theta equals 3. Now minus 3 sine cubed theta. Why? Because look, 3 times sine squared theta is 3 sine squared theta, but then you're multiplying it by sine theta again. So it's minus 3 sine cubed theta minus a sine cubed theta. And that means finally that if I have 3 sine cubed thetas and I lose 1, that's 3 minus 2 sine cubed theta. And that's sine 3 theta expressed in terms of sine theta. That's it. So hopefully you got that right. If not, try it again. Practice, practice, practice. Extremely important, because practice makes perfect.